why the universe is dark. The universe is not entirely dark, but it is true that a large portion of it appears to be dark. The reason for this is that the vast majority of the universe is made up of dark matter and dark energy, which do not interact with light or any other form of electromagnetic radiation that we can detect. Dark matter is a type of matter that is believed to make up approximately 27% of the universe. It does not emit, absorb, or reflect light or any other form of electromagnetic radiation, which makes it invisible to telescopes and other instruments that rely on light to detect objects. Dark energy, on the other hand, is a mysterious force that is believed to be responsible for the accelerating expansion of the universe. It is thought to make up around 68% of the universe, and like dark matter, it does not interact with light or any other form of electromagnetic radiation. The remaining 5% of the universe is made up of ordinary matter, such as stars, planets, and galaxies, which do emit light and other forms of electromagnetic radiation. However, even this ordinary matter can be difficult to detect in some cases, particularly if it is not actively emitting light or if it is located in regions of space that are obscured by dust or other objects. So, what is dark matter? Well, to put it simply, dark matter is matter that we can't see. It doesn't interact with light or any other form of electromagnetic radiation, so we can't detect it using telescopes or other instruments that rely on light to detect objects. This means that dark matter is completely invisible to us, which makes studying it a bit of a challenge. Despite its invisibility, scientists have been able to infer the existence of dark matter through its gravitational effects on visible matter, such as stars and galaxies. By observing the way that visible matter moves and behaves in the universe, scientists have been able to calculate the amount of mass that must be present in order to explain the observed gravitational effects. And that's where dark matter comes in. Scientists believe that dark matter makes up a significant portion of this missing mass. So, why is dark matter so mysterious? For one thing, we don't know what it's made of. Scientists have proposed a variety of theories about the nature of dark matter, ranging from exotic particles to undiscovered forms of matter. But so far, no one has been able to directly observe or detect dark matter, so we're still in the dark about what it's really made of. Despite all of these mysteries, scientists are working hard to uncover the secrets of dark matter. They're using a variety of techniques, from particle detectors to computer simulations, to try and shed light on this mysterious substance. And who knows, maybe one day we'll finally be able to see dark matter in action and unlock the secrets of this elusive substance. Until then, we'll just have to keep peering into the darkness and hoping for a glimpse of the unseen. There are several proposed types of dark matter, but none of them have been directly observed or confirmed. Here are some of the most popular types of dark matter that have been proposed. Weakly interacting massive particles, WIMPs. This is one of the most widely accepted theories of dark matter. WIMPs are hypothetical particles that are thought to be massive and interact only weakly with ordinary matter. They are believed to be left over from the early universe and could be detected using sensitive detectors on Earth. Actions. Actions are another hypothetical particle that is a candidate for dark matter. They were originally proposed to solve a problem in particle physics, but it turns out they could also explain dark matter. Actions are extremely light and would interact very weakly with matter, making them difficult to detect. Machos, massive compact halo objects, are another proposed type of dark matter. They are massive objects like black holes, neutron stars, or brown dwarfs that are too small to emit light and therefore are invisible. However, the amount of machos needed to explain the observed gravitational effects of dark matter seems to be much smaller than the number of such objects that have been observed. These are just a few of the proposed types of dark matter. While there is evidence that dark matter exists, its nature and properties are still largely unknown and further research is needed to confirm or disprove these theories. The concept of dark matter has been around for almost a century, but it wasn't until the 1970s that it became widely accepted as a valid theory. Here's a brief history of dark matter. 1930s. The first hints of dark matter came from observations of galaxy clusters by Swiss astronomer Fritz Zwicky. He observed that the gravitational forces within the clusters were much stronger than what could be accounted for by the visible matter in the galaxies, leading him to suggest the existence of dark matter. 1960s. The idea of dark matter gained more traction in the 1960s as astronomers began to observe the rotation curves of galaxies. These curves showed that the outer edges of galaxies were rotating much faster than what could be accounted for by the visible matter alone, suggesting the presence of additional matter that was invisible. 1970s. The concept of dark matter was solidified in the 1970s, when astronomer Vera Rubin and her colleague Kent Ford observed the rotation curves of several spiral galaxies. They found that the observed rotation curves could only be explained if there was much more mass in the galaxies than what could be accounted for by the visible matter alone. 1980s, 1990s. In the following decades, astronomers continued to observe the effects of dark matter through gravitational lensing, the large-scale structure of the universe, and the cosmic microwave background. Despite these observations, the nature of dark matter remained elusive. 2000s present. In recent years, advances in technology have allowed scientists to explore dark matter in more detail. Particle accelerators and detectors have been used to search for WIMPs and other hypothetical particles that could make up dark matter. Meanwhile, computer simulations have been used to study the behavior of dark matter in the universe and to better understand its properties. Today, dark matter is widely accepted as a major component of the universe, making up approximately 27% of its mass-energy content. While much is still unknown about dark matter, ongoing research and observations continue to shed light on this mysterious substance.